So here's a fresh example. This is where things are still going to go right, and then I'm going to show you what can go wrong, which relates to a question we've been asking for the last week or so. So again, the process here, it's not absolutely essential you switch the letters first, but it really is. I find it's the best order to do it. So we're going to write out just y equals -3 plus fifth root of 2x minus 4, as if we were just writing out the forward function itself and labeling the output y. And we're just going to switch the letters. That advertises conceptually, hey, we're and I just didn't do it. We're inverting things. We are switching the roles of input and output, and we're using that standard letter convention to say, hey, I don't want the output to be isolated at this point. I want the output to be in here, and I want the input to be isolated. And now I'm going to have to switch the roles. I'm going to just have to do the algebra to actually isolate y. So what are we going to do? Oops. Probably need to be down here. So I'm going to add 3 to both sides. So this is really good practice with the structure of algebraic expressions and how each piece works. I would say this is kind of on the outer shell, the outer layer of the onion here. We're going to do that first, and the order is totally going to matter. Okay, now this is a fifth root. How do you undo a fifth root? You take a fifth power of both sides. Groovy. All right, we're getting close. Now I'm going to add 4 to both sides. And now I'm going to divide by 2. And I'm done. I tend to like to see that on the right-hand side. So it's kind of another switch, but not nearly as important. And there we go. There's our new formula. That's the formula for the inverse. And it's already using the standard variable x as its input because we've made sure to switch the letters right away. Okay. So we could do the double check. For example, let's do a version where we have f inverse of x. So we're going to take this formula, that's the f of x there, and now we're going to plug in this inverse into here. It's going to look a little messy, but I'm going to put parentheses because this whole darn thing is going to go in here. It's going to look messy, but things are just going to cancel out beautifully. By design. Okay, so let's just double check. Is this really going to be what we want? And it does make sure, if we do it carefully, we can see that the order we did things in is correct. Notice the outer layer of this guy is the over 2, so it's ready to be canceled by the divide by 2. So I'm just going to cancel that all down. Now what's the outer layer? Hey, it's a plus 4, and that's going to cancel down, cancel with the minus 4. Boom, boom, boom. Now what's happening? Oh, look, the fifth root is now the outer layer of the onion, or sorry, the fifth power inside is the outer layer, ready to be canceled with the fifth root. All that cancels down, and then the minus 3 and the plus 3 cancel. Yay. It actually works. Okay. So you don't absolutely have to do that check, but it's really good to see that happen. So let me focus real quick on what can happen, what can go wrong here. Okay. This does not always work. It's really important. And we actually already have exactly the terminology of when this is going to fail. So let's look at one of our simplest, most beautiful functions. We've been doing this for a long, long time, squaring numbers. What happens if I say, if the output is known to be 4, what's the input? We're going to go back up to the very basic idea. I'm going to tell you the output of the square function, and I'm going to ask what the input must have been. And I need that to have a unique answer if I'm going to create a function that undoes it and only gives you one output going backwards. But wait a second. If I tell you the number, the square of a mystery number is 4, and unless I specifically restrict that to say being only non-negative numbers, that is ambiguous. I don't know which one it is. It is really unknown. What should I have? Okay, and so I cannot create an inverse function here. And that's kind of weird because, wait a minute, isn't it true? Isn't root x the inverse to x squared? That's how we kind of learn it. Root x undoes the squaring function. But the subtlety here is that, remember, when you square root both sides of things, we get a plus or minus, right? That's okay if we don't want a function, but it's terrible if we do want a function, okay? And so this is, it's the source of so many awkwardnesses, so many mistakes, needing to remember the plus or minus, various things about absolute values, all kinds of stuff that comes from the fact that you really can't invert this function. And remember, f of x equals x squared, we already knew this. We've been focusing on this a little bit because let's just remember what the plot of that looks like. That doesn't satisfy the horizontal line test. This is not one-to-one, and that exactly says that a particular output doesn't have a unique input that corresponds, right? So the problem here is that, let me make that a bit smaller, okay? In general, if a function is not one-to-one, a given output will correspond to multiple inputs. And therefore, let's say f, therefore f does not have an inverse. We're going to try to sort of skirt around this a bit, and we're going to chop up functions and sort of have amputated kind of partial versions of functions in order to try to recover something here. But if you're asked whether a whole function that's not one-to-one, that whole thing without any modification, if you're asked whether that has an inverse, the answer is simply no. A function, in other words, a function must be one-to-one in order to truly have an inverse. Notice that you might have noticed that I used odd roots and powers here. I used a cube, and that we had a cube root that undid that. And then I had a fifth root in this example, and we undid that with a fifth power. Those guys, no plus or minus, no ambiguity, those are one-to-one. And that was very intentional. You might have been like, why is he starting with weird roots? Why not start with x squared? This is why it's not one-to-one. It does not truly have an inverse.